Hi, today we're going to do Cal Academy String Set 2, Problem 9. So the problem says, find the longest common prefix for a given n strings. So, if our input is this array of strings, apple, ape, and April, our output should be AP. Since it's a prefix we're talking about, it means the beginning letters of a word. So, with that in mind, let's go through sort of the logic of this, of how this will work. So, what we will do, we'll find the shortest string in the entire array. And we do this because we know that that shortest string could potentially be the longest common prefix among all the strings. So, we grab that as our shortest string. Then what we do is we iterate through that shortest string, which is ape in this case. And as we iterate through ape, we're going to compare each letter of ape and its position to each letter and position of every string in the array. If they all look alike, we put a little check mark and we add that letter to our output. So we check if A at position 0 of all the other strings match. They do, so we add it to our output. We do the same thing for P, we add it to our output. And then we check the same thing for another P at position 2, and nope, it fails. So X, we don't add it to our output. So this will be done in a time complexity of O, N, M, because we are going to iterate through the length of n elements. And as we do so, we're going to be iterating for, iterate for m length, being the shortest string. So, and this is also going to be m space complexity, because at most space we're going to be reserving is our shortest string. So what we do first, we're going to have a couple helper functions. We're going to have this helper function to find the shortest string, which we'll do so by setting the, we'll create an element called smallest. We'll set it to our first string in the array. Then we're going to iterate from 1 and on, and then we're just going to do math.min of the smallest and the current element, and then return the smallest element, which will give us ape. Then, so that is found at this point inside of our main function called LCP for longest common prefix. We're going to grab the shortest string. Then we're going to iterate through the length of that shortest string, and we're going to ask a question. Basically, if all the letters at this position of every string match, then we're going to add that character onto our output called res. And all match will take in the current character we're on, take in the position or the index of this main loop here, and then the whole array itself. And we ask if the current string we're on at the shortest string's current position, if it's not equal to the current character we're looking at, just return false, because we know that there's no match. And if we do return a false, then we're just going to break, because then it means it's not contiguous. So there's no point in looking at the next character, because if it isn't there in one of them, then we shouldn't look at any other characters after ape. So then we break, because we could have a situation where we maybe have maybe if all the characters were like, let's see, it was like this, maybe if it was like this, AP, AE, AT, they don't match, but A, then P here, then A, P here, A, then P here, those match. But then it wouldn't be a contiguous prefix. So that's why we have this break condition, so that way we don't unnecessarily add P to our output when in actuality the output should be A. If this was our example. But for the previous example, it's apple, ape, and April, and we're returning AP. And that's how you do this problem. Thank you.